When we talk about different types of algorithms, we're going to see a lot of ideas that require us to create structures that contain no cycles or to be able to determine if cycles exist inside of a graph. And in this section, I'm going to be introducing to you a data structure that's going to be very helpful for us to use in that process of checking to see if a graph has a cycle. So before I go into the data structure, it's helpful to just refresh exactly what I mean by a cycle. A cycle is a situation where we can start at one node, we can traverse a set of unique edges, and end up back where we started. You can think of it as moving like in a circle or literal cycle of a graph, right? And typically cycles are done with directed graphs. So generally we say that a cycle is a situation where we have a directed graph where we could start on one node, traverse a bunch of unique edges, and end up back where we started. That's usually the definition of a cycle and the main one that we're going to stick with for this section here. Now, when we talk about cycles, there's a special kind of data structure that actually works very nicely for determining if cycles exist, and it's the idea of a disjoint set. A disjoint set is basically if we had a bunch of different sets of numbers, each of those sets would be disjoint if they didn't share any elements in common with each other. What we do with a disjoint set is we essentially represent them inside of an array, where each entry in the array represents a parent of an element in a set. So we could think of the elements in the set as like a tree, and each of the entries in our array is representing the parent of the current element that we're at. So what that basically does is it sets up a situation where we can have the root of the tree be what we would call the representative of the set. And we could say that basically if two of the values share the same representative or the same root, then they're a part of the same set. And we can use this to determine if two things are in the same set or not. And that's generally what we're going to try to do for our idea of a cycle. So the setup of this is actually pretty simple. It's mostly just understanding like how the whole process is working. Basically, all we really need is just a single array. And that single array is going to be called self.parent. And usually the way that we construct this is we just pass in a size here, and we can just make this basically a list of range size. And what this will do is it will basically just give you every single entry is going to be a value that is the same as its index. So, the entry at index 0 would be the value 0, the entry at index 1 would be the value 1, and so on and so forth. And what I'm saying to you is that each of these represents its root in a tree. So if I have, say, a list of numbers that looks something like this, right? What this is saying is that the parent of this particular value here is at index 2. Now, we notice that this value is at index 2, which tells me that it's its own parent. What that basically means is that it is the root of the tree. This one right here is also the root of a tree, and this one right here is also the root of a tree. So we basically have three distinctive trees or three distinctive sets of numbers, right? So it's just like three root values, right? So from here, you could start to add in additional information, right? So I could say this one has a value of 1. Basically what that means is that the third element here, its parent is at index 1. So its parent is right here over at index 1. So we could see that this one has a parent. So it's in the same set as the element at index 1, right? Now you'll notice that we're not really thinking about the values in this case. We're just trying to determine if something is or is not in a set, right? So this is a very interesting sort of way of looking at this. It's a bit different from the other approaches that we've looked at so far for things like, heaps, which are also trees inside of arrays. But in that case, we really cared about the values. In this case, we just care about their parents. If they have the same parent as each other, then they're in the same set. Otherwise, they're not. That's all we really care about. So that's the general structure that we're working with here. Two main operations that we may want to do. The first one is find, which will get us to find the parent of a node. So if I give it an index I, it will find the parent of index I, right? And the way that it does that is basically checks to see if self.parent at I equals I. And if it does, then that is the parent. Otherwise, what it's going to do is it's just going to return the result of recursively doing self.find on self.parent at I. So we'll just keep moving through the array each time, trying to find the parent. So if we were to do that with this node here, on the first iteration, the parent at I doesn't equal I, right? So it will recursively call it with the value at I, which is 1. So we'll come here, and then it will see that 1, the value at 1 is equal to 1, so it will return back 1, because that's the parent of this. That's how that process is generally working. Now, the second thing we may want to do is unite or union two different disjoint sets together. So basically what we do here is we just find the representative or the root of each of the sets. We could do that using our find method. So I could find I and I can find j. And then all I need to do is I just need to see self.parent at I rep equals j rep. That will unite the two sets together. It will change their parents essentially, right? So basically all that's really happening here is we're just changing the parents to be the same as each other. So if I had like a third one here that was, the value say, we'll just give this the value say 3, right? That would mean that its parent is 0, 1, 2, 3, this one right here, right? Now if I wanted to unite this around, a different element, say like this one here at index 2, I could basically just update this to be at index 2, right? Then it would be pointing to a different parent. That's basically all this unite is really doing here. So that's the main structure of our actual disjoint sets, right? Now the question is, how does this help us with graphs, right? And the idea is that it's going to allow us to be able to check if a graph has a cycle. Like I said, if something can start in one place, go to different edges, and then end up back where it started. So that's the main use case that we're going to see with this idea of a disjoint set. So what I'll do is I'll finish off this video here. In the next video, we'll take a look at an algorithm that we can use this disjoint set with in order to check if a graph has a cycle. So thanks so much for watching. I'll see you in the next video.